Hello all, welcome to the video. In this video, we will see one of these power supply circuit boards here and the common faults associated with it. And this one is a power supply. It is rated at 6 volts, 600 milliamperes. And see here, this one is a fuse resistor, a diode, the transformer, some regulatory caps, and here is some reference Z0.2, this one and this one, and this one. These two are the other reference Z0, and this one is the transformer, and this one is the switching transistor. It is named as M13001 NPN BJT, and this one at the last is a shortcut out 1N5819, and this is identical to this board. And in this board, the problems which I found here is that when the main problem was that when I connected to the supply 230 volts mains, there was no output coming, and and I checked every component present here, and the fault was this fuse resistor. This fuse resistor is actually a 2.2 ohm fuse resistor, and this resistor got actually burnt and it became open, and this one was a faulty resistor. This one got open, and that's why the mains power could not go to the rest of the circuit, and that's why I was seeing no output, and that's why I replaced this one, this 2.2 ohm fuse resistor to a big one. This actually has got some burn marks, but it is okay. The multimeter shows 2.2 ohms, and it is still okay. And after I connected here, in place of this, the output turns on and it shows 6 volts in the multimeter. See in this circuit 2, you will see this 2.2 ohm fuse resistor at the very beginning of the circuit. The mains comes in through this fuse resistor and then goes to the rest of the circuit. It becomes a high voltage DC, and then it switches to a low voltage 6 volts DC output. And I also think that changing these Z0 diodes can also change the output voltage too. This Z0 is rated at 6.2 volts and the output is 6.2 volts, and changing this Z0 reference can also change the output voltage too. But I need to check that. I need to pull it out and insert a 5.1 volt Z0, and then I have to check whether it is 5 volt coming or not. And other problems can be like you may see these electrolytic caps has been bulged out. It becomes fat, and it just becomes leaky, and you have to replace them. In that case, in many cases, this small value of resistor becomes open, and it shows infinite resistance. And the most common, such as this one is a 33 ohm resistor, and in many cases, if a large current flows and it destroys this resistor and it becomes open, in that case you have to replace them with new ones. And also keep and check of these diodes too, these diodes too. Sometimes they also get destroyed. You use the multimeter in diode mode and see whether a voltage of 0.4 to 0.6 volts coming or not. And you can also check this output diodes too. Since design series with the output, you may need to check this whether these are okay or not. And the transformer is all right, and Generally it does not become faulty. The main faults comes in these small resistance values, these zener diodes, these electrolytic caps. The most common is this fuse resistor present here. And actually, I don't have this small one 2.2 ohm, and that's why I have this bigger 2.2 ohm wattage. And but that's not a problem. The value should be 2.2, and the original board have used a point 0.5 watt 2.2 ohm, but I have used a 2 watt 2.2 ohm. But there is no problem with that. The supply will still run. But don't insert a quarter watt coupon to ohm. It may get burned. You may use zero point 0.5 watt coupon to ohm, or greater than that. So I hope this video might be helpful to you, and always use a digital multimeter with voltage, resistance, continuity, and dart functions. Also, it may be good if you have the capacitance measurement too. Here I am using a key-size multimeter. I used this multimeter to find the faults here, and at the very first stage I got this one open. And so I hope this video might be useful to you. And so please share this video with your friends, and please like the video, share it, and please subscribe to my channel for further such videos. Thank you.